So this is the last review video over Unit 9, Thermochemistry and Nuclear Chemistry. I know we went through this unit pretty quickly, so I'm going to highlight what's really important and what will be on the final. So let's look at thermo. Okay, remember, temperature is just a measure of kinetic energy. So as temperature increases, kinetic energy increases. Okay, and it's also directly related to thermal energy. Thermal energy is just the energy of motion. So if thermal energy increases, temperature increases. Okay, and how is energy transferred between two objects? Well, what happens when you put your hand on the stove? The heat transfers from the warmer object to the cooler object. So from the stove to your hand, and then eventually if you left it there, they would reach the same temperature. Now there's two types of processes, endothermic and exothermic. Endothermic reactions absorb energy, while exothermic release energy. And in terms of reactions, we saw this with the solutions lab. The one with the endothermic, the ammonium nitrate was endothermic because the temperature decreased over the reaction. And then I think we used calcium chlorate or calcium chloride, and that was exothermic because the temperature increased over time. So since endothermic reactions absorb energy, the final energy is going to be greater than the initial. So if you had a graph with energy over time, your initial energy would be down here, and your final energy would be here. Whereas exothermic, we would see the opposite. We start at a higher energy of our reactants, and then we're going to go down, and our products are going to have a lower final energy. The only thing else you need to know with the thermochemistry unit is how to use this equation, Q equals mc delta T. So I give you the equation, but you need to make sure you remember what those variables are. Remember, Q is heat, and this could be in joules or calories. M is mass in grams. C is the specific heat of a substance. How much energy, so joules or calories, is needed to raise 1 gram of the substance 1 degree Celsius. So C is that number that has a whole bunch of units with it. And delta T is your final temperature minus that initial temperature. So if we had a problem that said we were talking about water, and water's specific heat is 4.184, and it said we had 150 grams of water in a beaker, and our temperature, it was initially 50 degrees or 50.5 degrees Celsius, and it heated up to 70.5 degrees Celsius, and it would say how much energy was released by this reaction since the temperature increased. So I'd set up my equation, Q equals 150 times 4.184 times my change in temperature, which would be 20. Plug it in, 150 times 4.184 times 20. We get 12,552, and then according to sig figs I have 2, so 13000 joules would be my answer in this equation. So as long as you know how to use this equation, it is given in the problem, you'll be good to go with the thermo questions on specific heat. And the last part with nuclear chemistry. Okay, what's different about nuclear chemistry? You can identify a nuclear reaction because in the reaction you'll either see an alpha particle, that's the Greek letter alpha. It's also called a helium particle. Okay, you could see beta, or sometimes you'll see this as just an electron, or you can see the gamma symbol. which gamma doesn't affect the mass or volume. So you know it's a nuclear reaction if you see one of these funky symbols in your reaction. And nuclear reactions are different than chemical reactions because they are not affected by changes in temperature, pressure, or catalysts. So that's our main differences between them. Also, you probably learned from the video the difference between fission versus fusion. Fission is when the nuclei split apart. Fusion is when two nuclei come together. And the fusion process releases a lot more energy. It takes a lot more energy to bombard two nuclei together than it does to separate apart. Finally, the last part you need to know with the nuclear is how to do the half-life. I know some people were a little confused on this equation, so let's go through an example of the half-life. Remember, half-life is just the time it takes to cut something in half. Okay, so say for example, you were given 20 grams of a certain medicine, and you were told the half-life of this medicine was 6 days. Meaning every 6 days this substance breaks down and decays to half its size. So you wanted to know how much of this substance was left after, let's say, 24 days. Okay, so you can do this one of two ways. You can plug it into our equation. A is our final amount, A naught is our initial, times 1/2. T is the time itself, so 24 days, divided by the half-life, which is 6. So to simplify this down, 24 over 6 is just 4. So when you plug this in your calculator, you want to take 1/2 to the 4th power times 20, and we get a final amount of 1.25 grams. Now the other way to determine how much was left is if you just take your starting amount. We had 20 grams, and we were told that the half-life is 6 days, and the time was 24 days. So how many half-lives will the substance undergo? Well, 24 divided by 6 gives us 4. So this means this substance is cut in half 4 times. So you could cut 20 in half once, there's 1 half-life. Cut 10 in half, there's 2 half-lives. Cut 5 in half, there's 2.5. And I'm running out of space, but if we cut it in half again, there's our 4th half-life, we get 1.25. So if the equation is confusing to you, if plugging in the calculator is a little bit difficult, then go ahead and just cut it in half, however many half-lives the substance undergoes. So that wraps up the review videos. If you have any questions, let me know.